Hello, everyone. Welcome to today's webinar. We'll hang around for a minute or so to let everyone join. I see familiar names and faces. That's great.
Sure. It was nice to meet you last week in OSM meeting.
Hi, Arno.
Hi.
Great. To see if some of my old SGU colleagues joins too.
So good morning, everyone.
Morning.
Hi, everybody.
Is the audience truly worldwide, Gustav? It looks amazing, actually. Yeah.
I think most people that are here today are from geological surveys around Europe with a little emphasis on Northern Europe.
The diversity of names is amazing. It's great. It's great.
Yeah. Now I figure out how to share my screen. Okay, let's get started. Thanks everyone for joining today. What you got yourself into is a webinar that will introduce the Ocean Data Platform, and I will attempt bravely to do a live demo. Hope everything works. And the real highlight is, of course, the accomplished Chris Jenkins. Thanks for joining us today, Chris. He's gonna go through the dbSEABED data that is also in part available on the Ocean Data Platform. So we'll spend about 20-25 minutes on me going through the platform, and Chris have something similar, and then we'll have times for questions and discussions by the end, should you have them. And you can, of course, and very much encouraged to put questions in the chat while we're talking if you think about things. We'll try to, I think, to kind of go through the webinar, the demo and the webinar sort of to the end before we really address them. But we will try to give answers in the chat as well. And if we don't have time to answer everything, you can still post questions, and we will keep hacking away at the chat for a bit longer. Okay, great. So my name is Gustav Kegisten. I used to work for before I joined Hub Ocean, I was with the Swedish Geological Survey, and that is part of how I found you all today. I'm now the science director of Hub Ocean, and yeah, we are a non-profit foundation that are working on making ocean data more available in the world, and we believe strongly that it's important for a host of things from conservation to sustainable managed seas. It all starts with knowledge, and we try to make it more accessible to all. We also have our sister organization, Rev Ocean, and they will start being operational next year. They have built a one-of-a-kind research vessels. If you haven't seen it, I encourage you to do a little Google on Rev. And when they start being operational, we will also be their data, the endpoint for a lot of that data that comes through an advanced ship with lots of sensors. So our development of the Ocean Data Platform will continue to serve that kind of survey need. What you will see today is what we have built to really make global ocean data available and so on. So that's sort of at the heart of what we do. We have built this shiny machine that we call the Ocean Data Platform. It's The core features is an open data catalog with public data that it comes from both some unique sources through collaborations like with Chris. It also comes from open sources where we think that this data is very valuable and should be available with our technology. And it also comes from our ambition to get the industry to share more data. So you will find, and I will show some example of that today, some also unique industry data sets on the platform. It also has your own data space. So everyone that signs up, which is free to do, you will have your own space and you can use the same API-based technology to put your own data, collaborate on it, and also request to publish it on our open catalog should you want to. We also see the platform as a powerful back end to different websites, applications, and so on. So through the SDK, through the API technology, we can connect, of course, to the data from many other services. We also have workspaces, and we have this integration with GIS, which I will show you in a second. So I encourage you all actually now or later, go into the platform and play around for yourself. And it's easy to sign up. Just provide your email address and have a go. And so that QR code right there will lead you there, but otherwise you can just Google Hub Ocean and we'll get to our web page. Here on the web page, there's quite a lot of information about us. There's a FAQ session should you have more questions about who we are and so on. There are some examples of different use cases. And you have then the link to the platform, which we'll click to right now. Now I'm actually signed in to the platform. And when you're signed in, you have the catalog, your own data space, and a Jupyter Lab workspace that we host to give sort of equal access to compute facilities. When you're not logged in, these two will be grayed out on the right. And in the catalog, you can see the data and the metadata, but you cannot download any data and play with it. So for that, you need to have this free sign up. Okay, let's have a go at the catalog. And yeah, we are continuously, of course, updating the technology, but the core of it is a very fast API to make large geospatial data available and searchable, and you can also do some direct actions on the data here in the catalog. You can do a spatial search. If you go into the map and select your area, you can do a thematic search and of course the combination of them. If we just go first into a data set and we'll have a look at what that's like. This is one from protected seas. It shows marine protected areas around the world. So it's a global data set. It's a good starting point for those who wants to work with protected areas. When you go into a data set, you find, of course, some basic metadata. And you also get a first view of what's inside the data. And this is specific for vector and tabular data sets. So essentially points, polygons, lines, or just tables. They have a generic data format for the platform, which means we can do a lot of things on them. There are also files. So any kind of file can be on here. There's a file preview for PDFs and text files and so on, and images. Yeah, let's for example documentation and so on that might belong to this data set. So when you have a data set like this, yeah, this one is actually 20,000 rows, 87 columns. It's quite a lot. We do some pre-baked statistics so you can start having an idea of for each column what's there. Here, for example, there are 12,000 marine protected area polygons. We can go in and explore this data set, which means we're actually opening that data. At the moment, when you do that, you just see the first 1,000 rows in that data set to keep it very fast. But then you can go in and filter the data. And we can already display a lot more data than this. I will show you a secret trick in a bit. Anyway, so in this case, let's say we want to ensure we only look at marine protected areas. We could do that. Let's filter on those. We're going to look a bit at Norway today, so we could do a spatial filter as well on an area like this. And we can actually go and grab that specific data and download it if you want. So it's quite nice for those that don't want to talk with code, which you can do, of course, through both Python and R. You can do all of these kind of operations directly from your workspace. We did find 935 polygons around Norway. And again, yeah, so here you can start exploring a bit. And actually, we can also give these some color based on what's in each, in a column of your choosing. And we can change those colors if we want to play around. At the moment, you cannot overlay multiple data sets, but that's something we're working quite. I hope to have available quite soon. So essentially, it's a fairly already a fairly powerful little glimpse into GIS at this exploration level. Okay, and I want to show you on this data set another little trick. You can already do it yourself. Change data to map here. We are actually watching the same data set now, but using something called vector tiles. And this is our own, this is based on our own sort of technology. So what it does is that we now look at the whole data set, but in a tiled view. This is something that can be quite hard for data that is very complex. So we have not yet, made this a generic feature for the platform. We're still working on some of those really, really large data sets and how best to make this feature available. But it works quite nicely at this sort of mid-level data set that this protected seas data represents. For example, if you zoom in here, you will get the full detail of the data. Okay. Let's see, where were we? Let me go back to the catalog. Okay, so let's maybe in the interest of time, let's do one more. Let's have a look at. You can also search directly when you're looking for data. We can also do this sort of spatial search, and we can add something like seagrass or whatever you might want. And now what matters is if the metadata, the spatial metadata is overlapping this polygon. So it's at the moment not searching inside the data itself, but this is the kind of thing that the speed that is currently increasing quite a bit in the next round allows us to do so. But currently it's based on the metadata that has been developed. So again, it's another example of a data set with seagrasses. This is a global one. It has some additional information, and we can visualize that. Okay, let's go back to the catalog and let's have a look at what dbSEABED actually looks like. So let's search for substrate instead of, and we can actually also decide to just look at data collections. Not all, but many data sets are grouped on a collection. A collection is just one way to decide that data sets belong together. It could be a survey, it could really be anything. So there's not that much metadata here, but it is sort of a landing page, in this case for dbSEABED data. We have more flexible groupings on the way. So there is a bit of a playlist concept coming where you can play around with grouping data in different ways. But this is sort of a fixed grouping that is available. In this case here, we have one data set with just lots of documentation from Chris. So here you can already preview some of these and read some of the documentation PDFs. And then what we have here is a number of different models that you'll get a deep dive into in a bit. So these are model outputs from dbSEABED work, and this is since these are sort of, in this case, this model was published first here, and we have also generated digital object identifiers, DOIs, directly for this data set, which just brings you back to this page. So we can be sort of the repository or the main landing page for a unique data set. And at the moment you do that by request, but it's going to be a feature for all users. The data from dbSEABED here is as a geotiff. Now there is also a nice preview where we can have a look at what that data looks like, but to actually work with it, here we have to access the whole file and bring it into a GIS. So we don't have, at the moment, a full visualization function on the platform, but is obviously in the works and will be quite powerful when made available. Okay, let's go back at what's more in here. So there's a number of different model outputs here. There is also, and I won't go through them all because Chris is going to show you in a sec, but there is also the sample locations from dbSEABED, not the actual substrate geological information, but the metadata about the source. So again, here you can go in and you can see what's in that data set, get a first view. It's 4.3 million rows, so a bit larger. We can go in and have a look inside that data, and we could play a trick, which I think I did already for us here. So I can't visualize the 4 million points in an efficient way quick, but here we're looking at 100,000 points. Again, we could filter that and we could put some colors on it if there's something we want to look at already in this exploration. I don't know. Here, you can see what kind of data is actually inside. Okay, and then a third way that you can sort of consume this data is, so again, if it's a vectorized table data set, you can also connect to it through OGC features directly in your GIS. This is just a screenshot to keep it easy for us now, but in QGIS, it's quite simple to add the ocean data platform to your OGC features, and you can do that with ArcGIS as well. It has a good little documentation on the platform page. So this means you drag and drop your geotiff, but you can also then get these sample location, and that's quite nice. Again, for documentation, just go here and have a look at the OGC features. We also have the documentation about our SDK. It's essentially the package which allows you to communicate directly with the platform to read and write data and perform some compute. You do that either through Python or the just newly fully released R SDK for those that are working in R. And we have a Stack API as well. And then here's a general guide on how to get data into ODP. Okay, let's see if let's go back here. So, right, what I wanted to show you next is what happens in your My Data space. So if we move over to My Data, and this is here, I have a host of things, but what we actually had happening this summer was Chris was missing some data around Norway, and I picked up the phone to Norwegian Geological Survey, many of which are on the call today, I believe, and they graciously made some data available that wasn't yet available openly. And so I got a data set, and I was going to show you what it looks like when I took that, ingested it, and gave it to Chris. So you can create a collection. We can do that now. Perhaps you give it a name. You can provide some metadata if you want, and then we can add a data set. Like that. So now we have created a data set sort of landing page. What happens then is that from here you can add metadata if you want to spend effort at this point. You can also manage access. So access is for you can give access to anybody that has an account on the platform. If you hit the public link, it's also available as metadata for anybody. So here you can add admins, which means they can, do the same operations here as yourself, editors, and viewers. So this is a way to maybe develop either data or metadata together, and to work with maybe more sensitive data. You can also request to publish a data set, and that means we'll ensure just that it has the bare minimum of metadata and it's yours to be published, and then it will be on the catalog for everyone. You also, of course, importantly get this ID that's your key to talk to this data from anywhere else. So, okay, if we drag and drop a file, we can really drag and drop any kind of file. But if it's a CSV, a GeoJSON, or a Parquet or GeoParquet file, and we'll add more formats that's supported, the platform recognizes this as a vectorized data set, and we can ingest it as such. So you can add any other kind of file you want as well, but now it actually indexed that data, and we can go and explore that table, and we can have a look what's inside. So I'm now pulling a little trick, which I think we'll probably make available for everyone soon, but we can watch more than the 1,000 points you generically get. So here I'm watching the 12,500 points that's inside that data that was shared. And we can have some fun with it. We could filter it, of course, based on anything we want. But let's give it some color that makes sense to us all. Look here, this is sediment grain size. Chris, by the way, how did you translate all of the Norwegian names? Maybe you'll get to it in a second, but
I will. I'll show that. Yeah.
Yeah. Anyway, so here you can already actually see some of that data. Again, we could play with the color scales, and we can download it, and yeah. And this is what I shared to Chris. So yeah, that's about as simple as it can be to make this data available through the API. This was another data set with seamount. I wanted to show you one more thing. Yeah, we're also making some fairly large data sets available. This one is not yet in the catalog openly. You need to know the secret to find it, but this is a biodiversity data set from IUC UNESCO that we're working on, and it has 246 million rows, and it's actually quite fast already. Where you can filter on species, and I believe there's some geological information that you might have grabbed, Chris, for dbSEABED. Okay, last thing I'll show before I hand over to Chris. There are yeah, this is actually going to be an example of some industry data that was shared, and I'm starting just what was published. So when data is published, it often ends up in a repository if we're lucky. So this one, which was using industry data shared through one of our partners, Aker BioMarine, now Aker Krill Company, they did some work on acoustic data and published a krill data set. or actually predator-prey data set from Antarctica. And what ended up then, except for the publication, is a Zenodo data repository sort of dump of data. And this is of course great. It's now available. You can download it, but it's not trivial to start working with data. So let's see how I arrange this. Okay. Let me take one step back. So what's actually on the platform is over 500,000 acoustic raw files from fishing vessels in Antarctica. This covers 15 years. So these are data that can't be replicated in science very easily because it's such an immense amount of data for every fishing season. Here you can go in and explore all the track lines. Here they've been fishing a lot from different cruises. So this data is available for everyone to work with on the platform. It's split beam sonars, AK60 and 880. And the scientists picked that up and they actually did something pretty cool. They were able to extract, even if this was uncalibrated data, they extracted penguins and whale and fur seal signatures in that data. They published it, and then I brought that data back to the platform, and here you can actually go in then and see those detections again of the result. So here you sort of, what I wanted to really show was you can go from really acoustic raw data and trackline management and so on, all the way to the sort of end result. And a last thing, a promise before I hand over to Chris is in the workspaces we offer. And you can connect to any workspace you want in the cloud. If you're in Google Colab or something like that, you can also connect from there. But the workspace we have offer really a Python and R environment, and also a new JS project, which is quite cool. It's based on QJS, but made available through Jupyter Lab. So with that, you're already authenticated on the platform. I used that to connect to this data, and I plotted all the track lines, which is in our file metadata, and I opened the files directly with Python. And what you actually look at here is the penguin trails diving into the krill swarms. So I thought that was nice to say, because I know a lot of you work with maybe multi-beams or sonars and so on, and it's quite nice what you can actually crunch with open source Python packages and parallel processing and so on in the cloud. The scientists that did this at scale were able to process data that took them weeks and months in days and hours instead when they did it through our cloud. And that's all I had, I think. Yeah, okay. Sorry, one more thing, Cynthia. I just want to say also, when you work through our SDK, there are some things that can be done on the server side for those who are into compute and data. So it means that we can do, for example, something we call aggregations. So vector data can be processed on the server side, which means you don't need to move something. Like, for example, a habitat map or a geological map. We can aggregate based on spatial units, and we can aggregate based on themes. We did that just to show what it looks like for a bunch of data globally. This is what hexagons looks like. Here, this is steam mounts aggregated if they're located inside that hexagon, and you can populate it with lots of data. So there's a power of compute also on the platform side that we're developing. I probably talked too fast, but I hope that was understandable to some degree. And over to you, Chris.
Good. Thanks, Gustav. So I've been wrestling with the dawn light coming through. I had to put sunglasses on at one stage. But I think the sun angle's gone higher now. So, well, I just share the screen here. Okay, is it shared, Gustav?
I don't actually see it yet. I'll have one more go.
Okay.
If anybody had any sort of first little question, I guess we could use the time if Chris is struggling a bit. Then please free to voice and we'll...
So I'd like to ask, so it's pretty cool, of course, need to play around with this, but when you are in there in the platform, I saw that there's this support kind of window. Is it that via email, or how does it work if I have some problems, or how to contact?
Yeah, there is a form there that you can report issues and so on.
Okay, yeah, cool.
But I mean, and also you're free to of course send us an email too. I don't know.
Yeah,
you know where to find me.
Yeah, thanks.
But we are very happy for inputs from our users. This is still quite new technology, so there's always going to be things we need to work on. So we're very much happy to hear from you, and if we're not solving your problem today, maybe we can solve it tomorrow.
Yeah.
Radolf, please have a go.
Yes,
So
I wonder if you have been using GeoNorge to collect data from Norway.
We have some data from GeoNorway, but we could have more.
Because that is where NGU makes all our data available with all the descriptions and explanations and so on. Or we could say more about that.
Yeah, and in the example here that we made with the samples, those were not available at GeoNorway. But it was gracefully provided by your colleagues. Yeah.
Yeah. Okay. We show the same way of symbolizing seabed sediment types in our on our web pages at NGU. So I just wondered where you had got it. Okay.
Yeah.
So Gustav, this I'm not sure I've got permission to share, and when I do try, it sends me to Microsoft OneDrive.
Oh, that's not good. Let's see. Vigdis, do you have a chance to have a look too? I'll see what I can do.
Let me try, but no whiz on this one. Give me a sec and we'll figure it out. Meanwhile, guys, just keep asking questions and giving us your comments and your reactions. That's very, very helpful. And for those of you who wonder who I am, I also work in Hub Ocean, even though you can't see my face right now. But now let me see if we're able to give Chris some admin rights. Give me a second.
Chris, could you send me a PDF or a version of your presentation in worst case?
Yeah.
Is this a backup? Because it's actually our organizer, Sive, it's her birthday today, so she's usually on the call, but yeah. She let me just see what happened.
I'm sorry, everybody, we didn't expect this, but it seems like the Teams software has changed.
You should have all the rights, Chris, so it doesn't look like there's anything I'm able to do immediately.
All right.
Chris, did you send me an email and I can?
Yes. So. I'm just going to drag. Well, it might be pretty big.
So meanwhile, while they are
there we go.
Trying to fix that,
it's on its way.
Just asking if people are comfortable, what of what you have seen so far has been the most relevant to you in your either everyday work or a specific project. That would be very interesting to learn. And feel free to voice or even write it in the chat if you're okay with that. And I'll put my face on so you can see who I am.
Chris, are you sure you can't find the sharing? Because I think it's taking a second for it to make its way. You don't have the share content
Okay,
button.
yeah, this seems to be better now.
You're at least sharing.
Okay, can you see any of my screens?
Yes, we can. I will shut up
Excellent.
now. Take it away, Chris.
All right, very good. Okay, sorry about the glitch, everybody. So I'm speaking from Boulder, and the sun has just come up above the Mesa. So this is the second webinar that we've conducted through Hub Ocean, and I've kept the same sort of system. I believe, Gustav, that people can revisit the old one, the one in December. I think that might have been recorded, or the PowerPoint's available.
Yeah, they are. They're on our events page.
Right.
It's easy to find on the
Good.
webpage.
So this is an opportunity for dbSEABED to document itself in the public domain. So this morning, what I'd like to do is to just look at the importing of quite a large data set, 12,000 data points for the Norwegian EEZ. And I do want to thank NGU for making it available. It's valuable in a couple of ways. One of them is just the sheer amount of data and the seabed that covers. But also it was really a test of our systems because the data came in Norwegian, and we do like to bring data in different languages. We've done a lot in German, for instance. And yeah, so it was a good test of the system. dbSEABED is a research project where we're feeling our way forward, and it's based mostly at the University of Colorado in Boulder. It aims to get global coverage of descriptions of the seabed materials. So we're not really concerned with bathymetry. We're really focused on the materials. And of course, that has a lot of applications in ecology and use of the seabed and sediment transport and so on. So I'm showing you a graphic here just to introduce the total system. The colored graphic is a representation of hard substrates, mixed substrates, and soft substrates on an ecological scale, going from +1 to -1. And that's on worldwide. I think this resolution is 0.1 degree. And on the top part there, you can see the data coverage. Now, of course, those points are not all rock. And we're finding in this research project that we have to innovate as we go along. So all these points here are actually including rock records, but also where people have taken cores and found no rock, right? So the amount of data that addresses one parameter can be quite surprising sometimes, and you do have to think laterally on how to get the global coverage. So yeah, so that gives you an idea of the scope. The leading features of the system, it is large, 6 million observations now. We've been at it for many years, just steadily creeping up in the amount of data. And our focus is on the data. Other people are better at doing interpolations and predictions, spatial predictions, but our focus is really on the data, and we employ a fairly conservative interpolation method by comparison with other groups. So we're interested in working with other groups to strengthen that. So dbSEABED concentrates on supplying engineering units. So grain size in phi, carbonate in percent, seabed strength in kPa, as much as we can. So The reason why is we want to interface with models and we want to be helpful to people. So we tend to shun doing classifications. We want to work with measurements in units. So we really want to interface with models. And then this morning, what I want to look at is a factor that makes dbSEABED quite different from most other data sets on this topic. And that is that we incorporate word-based data. It's an extremely strong part of the description of the seabed. 85% of the data we have available comes to us as word-based data. The rest, of course, is analytical data. So by using word-based data from many different disciplines, we fight bias. So we're really all the time trying to get a least biased measure of the seabed. And the word-based data helps with that. We calibrate as we go. There are internal calibrations right through dbSEABED, and I'll show you some. And I do want to emphasize that we are research-oriented. So with word-based data, it steps in and does things that numerical analyses, numerical results from analyses can't do. And here are some seabed types which absolutely need word-based data to characterize. Things like forms of objects, colors, consolidation states, odd outsized objects. Word-based data is required to cover those. Now, what is the arithmetic or mathematical basis of bringing the word-based data in? We think along the lines of fuzzy set theory. So if somebody says medium sand, then that in the way people use that term, that has a membership function which relates to phi values of the sediments. So it's not an exact thing at all. We use the concept of a descriptive term representing a membership function of quantitative results. This has worked really well over many years for the imputation of many, many data sets of all different sorts. So how do we bring this into outputs? Basically, it's a bookkeeping. There's nothing really fancy to it. We have a description like slightly muddy relict bryozoan sand with shells. And we have a markup language that brings that into a format that's rather arithmetic, right? It brings it into a sort of a formula format. And that markup language, again, has proven itself time and time again with many different data sets. And this morning, I'll show you with the NGU data set. So we can analyze that description for grain size fractions like gravel. Where's the gravel in that description? It's the shells. So there's a representation of a gravel fraction. That's certainly mostly sand, but there is also a mud component, which is slight. So we do the bookkeeping there and then produce results for carbonate, for grain size fractions, etc., etc. Okay, so let's dig into the NGU data set. It was big. And it's complex. Many parameters in the original table. And the first step is to divide them into what I call housekeeping parameters like position and quality flags, naming, database keys, and so on. So the housekeeping here is shown in yellow. And then the parameter data for the nature of the seabed is shown in green. And the language here is Norwegian, although I noticed that there's English and German and maybe other languages scattered through. So most of these terms we like to translate to English, but some of them can't really be translated. And so we enter the Norwegian terms directly in our database and then consult colleagues to find out what those terms mean. So one here is crow bells. We still actually don't quite know exactly what that translates to in parameters. So here we've got the English translation of one of the entries in this 12,000 long database. And in the gray box here, you see that we've changed it to markup, to the dbSEABED markup. It's similar to what I showed before. So basically that markup flags which terms are objects like shell or sand, which terms are modifiers like coarse or fine or yellow or cemented, and which terms are quantifiers like with or slight or purely, and so forth. There are some other types of terms like operators, and you can see an @ symbol there, which is what we call a locator. It gives extra information on the disposition of things. So the main ones to concentrate on are the quantifiers, modifiers, and objects. And so you can see the with quantifier is marked with a backslash that points to what it's quantifying. And in the fourth box along in the gray area there. So with pure shell sand, and that means that it's not the full amount of pure shell sand in the sample. It's a secondary component. Our software analyzes that type of markup syntax and then produces estimates of things like gravel fraction. This here underneath in the white is an actual extract for that same sample out of our main data file. And the dbSEABED software takes all of these lines for that sample 6278 and combines them, collapses them into one result for that sample. So the grain size, the color, the composition all lie alongside each other, and they talk to each other in one record, which is represented here. I'm sorry about the detail, but this is a detailed business. This is a GIS-ready table. You can see the column headings there. They're pretty standard. This is our top 20 of parameters: gravel, sand, mud, clay, folk code, rock membership, carbonate, organic carbon. So these are the categories that we harmonize data into. And then you can see the results for that same sample underneath. You can see that we've got sand, 99%, a little bit of gravel, a little bit of shell gravel, and then 85% carbonate, which was measured. And then the color of the sample was noted at 2.5 Y7-2 in Munsell code. So this is eminently plottable in GIS, and it goes great into numerical models, and it goes great into interpolation models. And you can see on the side there that this is the end result from the current dbSEABED mapping in the Norway area. And it's showing phi grain size interpolated across the map. And then the distribution of samples, including the NGU. So you can see why I'm grateful to NGU. The coverage for Norway is now very, very strong in combination between NGU and the already existing dbSEABED data. So thanks, guys. All right, so the question then is quality control. Over many years, we've been doing calibrations of this process. And here's the result of an early one that was done on the DDR, the East German samples in the Baltic Sea, in the Southwest Baltic Sea. And we applied these methods to that data set. Sand, sehr fein, schlickig, wenig schwach. Right, so we can deal with German terms in dbSEABED. And we did a cross correlation of the analyses and the descriptions, because in this data set, both were available for every sample. And we got this result with the mud contents. The median average deviation on the mud contents turned out to be about 3%, which was an excellent, excellent result. We don't get that in all data sets. So we also apply this to other data sets, and we apply it to some other parameters, not all. And here we have a comparison of the parsed, that is the word-based data, the PRS in blue points here, compared with actual measurements with grain size analyses. And you can see that there's a reasonably good correlation. Now, there's a bit of debate about what the culprit is for spread. Grain size analyses tend to be done on extremely small samples. And I question whether they're really a good representation of the seabed in gravel size. Visual descriptions are great on gravel, but very poor on fine grain sizes. So both of the methods have something to offer for a realistic, unbiased description of the seabed. Okay, so that's what I wanted to cover this morning, and how to obtain the outputs. There are several methods. Some of the deliveries are getting a bit old now, and we're looking to upgrade them, but I'll mention the USGS US seabed. You can get data from Instar in Colorado. And of course, this morning we're looking at the Hub Ocean delivery system. So thank you very much, and look forward to questions.
Thank you so much, Chris. And for those that want to see a bit more about the global models as well, I think there's a link there to the webinar we did in the fall, which was including a bit of additional detail.
So particularly, we've got people from NGU and nearby countries on the call this morning. So I'm totally eager to follow up with them, answering any more detailed questions they may have on the methods, Gustav, right?
Yeah, and if you see the chat there, Chris, you already got, of course, an answer to your question about the crow bells. It was a fun translation from Norwegian to English, but it's your sea urchins.
Yes, right. The echinoids, yes. Okay. And presumably the regular ones. Yeah. Okay.
Okay, great. So we have a couple of minutes, and see, Terje, you already have a question. So over to you.
Yeah, this is Terje Torstens from the Geological Survey of Norway. Sorry, my camera doesn't work, but I guess it doesn't matter. It's not really a question, just a comment. This is very interesting, and I think particularly, well, there are very interesting approaches, but this approach we're using this word-based way of digging into data. That's really new as far as I know, and very interesting. And in fact, I think that's something that is really new and innovative. And when it comes to the data compilation, in fact, Margaret and me and Lilia, we are working now on contributing to the work on revising what's called the particularly vulnerable and valuable areas of the entire Norwegian continental shelf, which is about 2.1 million square kilometers. And of course, we have quite a lot of data, but I will definitely try to get into this and have a look for the additional data collected by all the other organizations, because I mean we have so vast areas, and any information from external sources is valuable. So I think this is a great effort. It's rather complex, so I think we need some time to dig into it, but I'm sure that you are there in order to assist us in finding out what is possible. Thanks.
Yeah. Oh, good. Thanks, Terje. So, yeah, we are doing similar for the Australian EEZ at the moment through Geosciences Australia. So they have a very large mixed source data set. And so we're wrangling with that at the moment. It's a very similar exercise for all the countries.
So Terje, when you do that, of course, Chris is the source of truth, but you can as I showed you, you can already make a spatial selection in your area of interest on the Ocean Data Platform, and see. And this was before the Norwegian data was added, but you can already then extract that data and see the main holding of dbSEABED. And Chris, I believe you might have some other additional data on the shelf too that maybe can be dug out in more focused work, of course, but
Right.
that's easily available.
Yes, well, I must absolutely thank the parallel efforts. I mean, the Pangaea database is mighty, and we do import that, and so it really is an effort where we can join forces in many ways between countries, between databases. Yeah.
And it's so nice that it's in a way harmonized, even though, I mean, it will never be perfect harmonization, but getting all of these data into a common platform where you can see all or most of the data and being represented in a fairly harmonized way is that's really good.
Thank you.
Okay, do we have any more questions from audience? Chris, I have one for you. When you did the kriging modeling version on the Ocean Data Platform, what additional environmental data did you use?
Yeah, our interpolation is very conservative. So, apart from bathymetry, if you want to use environmental data to help the interpolation, things like ocean currents or temperatures or so on, actually that data is sparser than the seabed data. And a lot of it is really highly modeled, like the seabed currents. And so we decided to, again, really focus on the data, and we employ quite a conservative interpolation. The only supporting data we use is bathymetry.
And you only use the depth, or you use the derivative?
We only use the depth. We don't use BPI or any of those other things, although I like those statistics, but we decided to not develop a black box interpolator. It's a completely open, understandable, locally operating, hard on stationarity criteria, and it's a conservative but very effective one. It works really well around submarine canyons and up the sides of seamounts, and so basically the only supporting environmental data we use is the bathymetry, the water depths.
Very good. Okay, over to Marcus. I see you have a question.
Oh, good. Yeah.
Yeah. Hello, Chris.
Hi, Marcus. Yeah.
Good to see you. So I guess it's to both of you. So I'm not quite sure. Maybe I missed it, but are these data points? You said you're mainly into providing data rather than mappings, and maybe that's my part to do the interpolation.
Mm-hmm.
So are they actually available via the ODP or directly?
I can start.
So in the old days when we had to have this exchange, and then you would, for a small fee, would provide me data. So that's what I remember. But is it now actually integrated and it can be just downloaded as data points? Or is this?
Yeah. I'll start, Chris, and I'll head over to you. No, so what's now publicly available on ODP are the global models that I briefly showed you. So all you need to
Yes.
do is to sign up, and you can download those files.
So there will be geotiffs of,
Yeah, the
for
geotiffs
example, hard substrate or something like that.
geotiffs, and also, which I think can be useful for this audience, like we talked with Terje, the actual locations with some metadata of the points inside dbSEABED. So that's actually over 4 million points there that you can use. But for the, like Chris showed, for higher resolution, maybe I'll hand over to you, Chris.
Yeah, good. So yeah, so we're not supplying the point parameter.
No.
Okay,
No,
we're supplying a global interpolation of the data at 0.1 degree. That's the public. And you know, in this field, there's sensitivities by many nations about releasing public data around their harbors and their shipping choke points and everything like that. So we have to take care of that. Otherwise, they wouldn't cooperate with us. So, however, we are able to collaborate with people and provide that point data for research purposes, right? So you and I should really talk about that in terms of carbon, because we're holding a lot of organic carbon data. It does need some work because of issues like carbonate-free measurements versus the bulk, right? But yeah, let's work together. dbSEABED is a research project, and we're really keen to further ocean research. Yeah.
Okay. Yeah. Thank you. Yeah. I guess I'm also asking on behalf of colleagues from the UK who asked the question to me: is there any good global data on? They were interested in sediment data groups, so sand, mud, sand, gravel, and the likes. So I might actually point them to you in this case.
Yeah.
I guess.
And I also show them the open data already there. So there's already that model on, which includes the grain fractions. Okay,
yeah,
over to Margaret.
I already downloaded it.
Yeah, contact me, Marcus. Very good.
Yes. Okay. Thanks.
And yeah, I should mention we're striving on a yearly update on that model, but maybe there'll be more updates. That's up to Chris. But we've done 2 already, about a year apart. Margaret.
Yeah, hi. See, Angie is hogging all the questions today, so I don't know. Anyway, I have downloaded the this hard versus soft data set already from you, and it looks really nice. One thing that we're interested in, we've got some projects now going even further north, and I wondered if it would be possible, because I see even if we like reproject the data to polar and things, there's still some kind of pole-related artifacts. I wondered if that's something that you already have on your wish list, is to generate like a polar optimized version of these grids. It would be super useful for us.
Yeah, we do have IBCAO coverages, right, in polar coordinates. Yes.
Okay. All right. I need help to find that on the platform.
Yeah, they're not being served because, well, they're you know, merging the polar coordinate interpolations with the unprojected lat long things creates a suture, and so we have to solve that really before we serve it as a unified thing. But we certainly have a good IBCAO coverage for the Arctic. So send me an email and we'll see what can happen.
Thank you. Yeah.
Good.
Great question. Okay, thanks everyone. I think we're closing the meeting, but again, if you think of something, just reach out to me and Chris or any other one of us, and you can also, I think we can keep an eye on this chat if you want to use that. It will be open for a bit more. So thank you so much, Chris, for joining.
Yeah.
Thank you everyone for showing up and having lots of good questions. And yeah.
Thank you very much, Chris and Gustav. Okay, bye-bye.
Good. Okay.
Bye-bye.
Do well,
Great to
Thanks a
see
lot.
some.
Thank you. Bye-bye. Thank you.
Bye.
Bye.
Bye. Good to see you all.
Nice group, Gustav. Yeah.